Hokie dokie. Shifting gears here a little bit, they ask us to examine the vertical and horizontal asymptotes for each of the following graphs. So, just as a brief review, I suppose, any vertical asymptote is basically where the graph is like, each, I don't know, it's like split up. Basically, it's a discontinuous x value for which the function goes about it vertically, or it could come down from the top and do something like that. But basically, that's what we're looking for vertical asymptotes. It's a split in the graph. For horizontal asymptotes, how I would like you to think about it is as the function goes left and right off the graph. The question is, does it level off at some y value? If so, that is a horizontal asymptote. I want you to kind of clear that notion that you might have learned, that I learned even back, say, in high school or something, about the function cannot cross the horizontal asymptote. That's not true. It can't cross it as it approaches to the left and to the right, but this is a horizontal asymptote for number 2. This is a horizontal asymptote for number 2. And even though it's crossing it, technically that y values, like these y values here and here, it's hitting those y values. I don't know. So basically, just think about it like this. As it goes off the graph, if we extend these functions left and right, the question is, do they level off at a y value? For number 1, they do not, because this is going down, so it's not leveling off. And then this is going up, so that's not leveling off. So 1 is out of the picture, because in this case, they ask us to determine which graph has at least one horizontal asymptote. And so for number 2, this goes to the left and is already pretty flat. So it's leveling off here at y equals 2. And the second one over here is leveling off at y equals 5. And that's it. So it has 2 horizontal asymptotes and also 2 vertical asymptotes, 2 splits in the graph. And number 3, these are just going off to infinity, so they're definitely not leveling off at some value. So in this case, 2 is our answer. Let's go and do 2 more examples real quick. In this one, they say determine which graph has no horizontal or vertical asymptotes. So in this case, number 1, great example of a function that crosses its horizontal asymptote a bunch. So regardless of it oscillating nonstop, as it goes to the right, it's still leveling off eventually at y equals 2 on both sides even. And so this does have a horizontal asymptote at y equals 2. And again, we're looking for the one that does not have any asymptotes. Number 2, if it looks like this, it definitely has asymptotes, right? It's leveling off over here to the left and then to the right, and then here and then here. This has 2 horizontal and 2 vertical. Number 3, it does have this oscillating pattern, but it's oscillating sort of in an opposite way that number 1 was oscillating, right? So number 1 started very wide open, and then it narrowed out, it leveled out as it went left and right. In this case, it starts very flat, but then as it works its way outward, it's getting wider and wider and doing something crazy like that. And so this one would not have any horizontal asymptotes, because as it goes left and right, it's not leveling off at any one y value. And then there are no splits in the graph. There's no vertical asymptotes where it does something like this or something like this, whatever. And so number 3 is likely our answer. All right. One more example. They say which graph has at least one vertical asymptote. Okay. So number 1 does not have horizontal asymptotes because it's not leveling off, but it looks like it does have a vertical. So 1 looks good so far. Number 2, again, looks like it has horizontal, but no vertical. We don't see the split like we do with number 1. And then same graph that we saw in the last one, this had no horizontal or vertical asymptotes. So number 1 is our answer. If you have any questions on analyzing any of these asymptotes or these graphs and their asymptotes, please let me know. I hope this helps.